Okay, now let's take a look at exponential equations. And again, you've solved exponential equations before. It's just an equation where the x is in the exponent and you're trying to figure out what that x is in the exponent. And so one thing to note is that there's no restriction for what an exponent can be. In contrast to logs, we can't take the log of a negative number, 0, right? But we can raise 2 to any power. We can raise 3 to any power. So the exponent can be positive, negative, no restrictions. And so one thing that you don't have to worry about is extraneous solutions for exponential equations. And so again, let's take a look at two examples. The best case scenario is when you have an exponential equation where you can match the bases. And so if the bases match, like for example, if 2 to the 2x minus 3 has to equal 2 to the 5x, well then, in order for the left and right side to be the same, 2x minus 3 would have to equal 5x, right? And so you're using the one-to-one property again for exponentials. And you're saying, all right, if I can match the bases, then I know that the exponent has to be equal, and I can just solve. So negative 3 equals 3x, and x equals negative 1. All right, now let's take a look at the problem on the right. It looks a little bit more complicated, and I still want to solve the exponential. So that 2 is not part of the exponential, right? The exponential is 3 to the 2x minus 5. That 2 that is being multiplied in front is not part of it. So the first thing I want to do is to isolate the exponential part of the equation and undo anything, move anything that I can move. For example, that 2, let's divide it away. So 3 to the 2x minus 5 equals 7. And now at this point, I have an exponential equation. Your options are, I either can try to match bases, and if that works out, great. And then if you can't match bases, then we have to use another strategy. We have to take the log of both sides, because then I can take the exponent and move it down to the front of the log, right? So at this point, I look at my problem. It looks very similar to this on the left, but I can't rewrite the 7 as 3 to a power. So I can't match bases. So you always try to first, because if you can match bases, it makes things easier. But if you can't match bases, then we're going to take the log of both sides. And I'm going to show you two ways of doing that. So option 1, we can take the common log of both sides because we have the log button on our calculator. So I'm going to take the log of 3 to the 2x minus 5 equals the log of 7. Okay, and remember, it's just an operation. Just like how you can take the square root of both sides, you can cube both sides, you can take the log of both sides. And once I do that, I can use the exponent property of logs and bring this exponent down to the front of the log. Then we would have 2x minus 5 times the log of 3, which is just a number, equals the log of 7, which is just a number. And then you can divide this number, the log of 3, with your calculator. Okay, so with your calculator, you would do the log of 7 divided by the log of 3 because you have a log button. And then you can add 5 and divide by 2, and you would get the x all by itself. So if you can't match bases, you take the log of both sides in order to bring down that exponent, and then you can solve it like a regular equation. Another option, instead of using the common log, because when you take the log of both sides, you can really choose any base that you like, right? A lot of times we like using the common log or the natural log because we have those two buttons on our calculator easily available. But there's another strategy that might cut down on a step. And that one is, instead of just taking a common log all the time, you can take the log with a base that matches with the base of your exponential part. And so the exponential part is right here, 3 to the 2x minus 5. So instead of taking the log base 10, we could take the log base 3 of both sides. I'm going to show you what happens. Okay, so I'm going to take the log base 3 of both sides so that that base matches with the base of this exponential. And I'm going to apply the same log rule. I'm going to bring the exponent down to the front. and it will become 2x minus 5 times the log base 3 of 3 equals the log base 3 of 7. And why that skips one step is because it skips the step of dividing, because what is this? Log base 3 of 3. Base 3 raised to what power would give us 3? That's just 1. Right? So that kind of cancels out and you don't have to worry about moving it to the other side, and you end up with 2x minus 5 equals the log base 3 of 7. And then you can add 5 and divide by 2. Same thing. At this point, some of you might wonder, well, how do I type this into my calculator, right? On your calculator, you either have the shortcut, so you click on math, and then you arrow down to log base, and you can type in any base, or using the change of base formula to type in the log base 3 of 7, this is just the same as log 7 divided by log 3. So it's literally the same thing, okay? Whatever you prefer. And so again, I'm gonna have you guys pause and take a few minutes, maybe 10 minutes or so, and try and see if you can figure out some of these examples, 5, 6, 7, 8. 8 is a little different and it is a little tricky, so give it a look and then you can check back to see how I did number 8. But 5, 6, and 7, we should be able to try and figure out. So give it a try and then skim forward in the video to see if you got the correct answers, and then just skim back to the problems where you didn't get the correct answer and watch those parts. All right, so number 5, my exponential equation, the bases already match. Awesome. So I have negative x squared equals negative 3x minus 4. They have to be equal. And I have a quadratic, so let's set it equal to 0. X squared minus 3x minus 4. When you set it equal to 0, we always try to keep the leading coefficient positive. That would make it a little bit easier to factor. And so factoring, that's going to give us x minus 4, x plus 1. So x equals 4. Or x equals negative 1, and they are both valid answers. No restrictions for what an exponent can be. All right, for number 6, that 4 I can kind of move away and undo first before I worry about the exponential. So I have e to the x equals 10 divided by 4. I'll rewrite that as 5 over 2. Okay, and now I'm looking at my exponential equation. I can't match bases. At least it's not easy to. So for this problem, I'm going to take the log of both sides. Now, if you have e in the problem, the easier log to take will be ln. So whenever I see an e and I have to take the log of both sides, I would choose ln. And I'm going to show you why in a minute. So I'm going to take the ln of both sides. And then I'm going to bring this exponent down. So this is x times the ln of e equals the ln of 5 over 2. And you might see why already, because remember ln of e is 1, right? Because that's base e raised to what power is e, and the answer is 1. And so your answer, x is isolated, is just the ln of 5 over 2, whatever that is. That's the exact answer. If you want to type into the calculator and round to a decimal, to the nearest 100, that's 0.92. Okay, either answers are acceptable, either the exact answer or if you want to change it to a decimal. All right, for number 7, very similar. That plus 10, we can move that first. And then we would have 6 to the negative x equals 37. And again, I can't match bases. It's not easy to. And so we're going to take the log of both sides. Okay, so you could take regular log of both sides, or you could take log base 6 of both sides. Entirely up to you. All right, so I'm gonna take log base 6 of both sides to match the base of the exponential. And then I'm gonna move the exponent down. Negative x times the log base 6 of 6, which is just 1. And then I can divide both sides by negative 1. So x is negative, whatever the log base 6 of 37 is. And you can type that into a calculator, or that is your exact answer. Okay, so if you type into the calculator, you can either use the shortcut, or you would just type in common log of 37 divided by the log of 6. And that's what you would end up doing if you took the common log of both sides at the beginning instead of taking a log base 6 of both sides. And so you get x equals negative 2.02. Okay, exact answer versus rounded answer. Okay, last part, number 8 is a little tricky because there are two exponential terms that I can't combine. And I can't get them to be 1 to 1 because then there's still that minus 5 in the problem. Okay, I'm going to rewrite this equation and see if you notice anything. Instead of writing it as e to the 2x, I'm going to rewrite this as e to the x squared. That's the same thing, because inside outside parentheses, you multiply the exponent, so it'll become 2x. Minus 4 times e to the x minus 5 equals 0. Notice that it looks very much like a quadratic. So let's make it a quadratic to simplify our problem for a little bit. And to do that, we're going to use variable substitution. I'm going to let u temporarily take the place of e to the x. And then we can rewrite this as u squared minus 4u minus 5, and that all of a sudden looks much better. So let's factor and solve for u, and then we'll put the e to the x back. So u minus 5 plus 1, u equals 5, u equals negative 1. Great, I solved for u. Let's put the e to the x back because ultimately we want to know what x is. So e to the x equals 5, or e to the x equals negative 1, and you really have two mini exponential equations. Right, let's look at the first one. E to the x equals 5, can't match bases, so we're going to have to take the log of both sides. And because there's an e, I'm going to take the ln of both sides. Okay, I'm going to take the ln of both sides, and then I'm going to move that exponent down. And I know the ln of e is 1. So one of my answers is the ln of 5, which is roughly 1.61 if you type in the ln of 5 in your calculator. Okay, and then there's that other mini equation. I'm going to do the same thing. Take the ln of both sides. Bring down the x. The ln of e is 1, and so x equals the ln of negative 1. Now, if you try putting this into your calculator, it's going to give you an error because we can't take the log of a negative number. So this is actually, doesn't work. Okay, that's undefined. And so your only answer is the ln of 5, or roughly 1.61. All right, so practice is your homework. And for the practice, it's a mix of exponential and log equations. So quick summary, for exponential equations, you either match bases, or if you can't match bases, then you take the log of both sides to bring that exponent down. And you don't use a calculator unless it's absolutely necessary. The only time when you should be using a calculator is when you get down to like the final answer and you want to figure out what the ln of 5 over 2 is, or down here if you need to divide to figure out what the log of 37 divided by log of 6 is. All right, and that's what I want you to do for your homework. You're going to solve each equation, and don't use a calculator unless it's absolutely necessary at the end, in which case you can round your answer to a nearest 1,000 or 100.